Hello. So now today we will discuss a sample mode 0 program that will clearly demonstrate how 8255 can used as a peripheral device and how it can interface clearly an input device. In this example here we used an example of input switch and we output the switch data to corresponding LED. So now the problem statement, you can see that write a program to read the digital input switch and display the reading from port B and port A from port C lower and port C upper. That means we have to connect the digital input switch at port B and port A of 8255 and display the corresponding data to the corresponding port. Here the figure, you can see the figure. In this figure you can see that here port B and port C lower is used as input port, okay, and port C upper and port A and used as output port. So you can all know that the switch acts as an input device. So as port B and port C lower acts as an input port, so we have connect here digital input switch as an input device, and as LED used as a display device or an output device, so we have connect the LEDs to corresponding port C upper and port A, okay. So now before discussing this problem, we have to mark that port A address is 8000, okay, that means A1 and A0 is 0. Port B address is 8001, that means A1 is 0, A01, A1 is 0 and A0 is 1, and port C address is 10, that means 8002, and control register address is 8003. These four addresses needed to transfer the data between these addresses, okay. So port A 800, port B 8001, port C 8002, and control register 8003. So next, the control word format. As I have said that the control word is actually first loaded into the control register. Now I am again repeating the control word format. Here the control word is the bit D7 is for the IO function. That means if it is 1, it is set as simple IO mode or the IO function. So here it is a mode 0, simple IO mode. So here we have said D1, D7 is equals to 1. Next it is mode 0 example, so we have said this D6 and D5 as 00. And next port A is used as an output port, so that in every in the control word, if it is set to 1, every bit is set to 1, corresponding bit for the corresponding port is set to 1, it is used as an input port, and if it is set to 0, it is used as an output port. So here we have make port A as an output port, so that's why it is set to 0. Next we have used port C upper as an output port, so or output port, that means we have connected LED to port A and port C upper, that's why zeros are set to these two bits. Next port B, for the case of the mode 0, this D2 bit is used, that's why it is in mode 0 representation. Next D1 and D0, it is used for port B and port C lower. At port B and port C lower used as an input port, that means DIP switches is connected in this port, so we have used 1 and 1 in this configuration. So combining all this, we can get 83 hex as an control word. So we have to load this control word in the control register before proceeding further. So MBI A83 hex That means we have to first load the accumulator with the control word format. Next we have to move the control word into the control register. So in the previous previously we have seen that 8003 is the control register address. So we have to first load this into the control register. So that's why STA means move the content of the accumulator to the corresponding address. Corresponding address means control register 8003. So we have moved 83 into the control register. Next 8255 will read the control register and decided the action according to that. So LDA. Next we have to read the switches at port B. Okay, so after reading the control register, 8255 will automatically know that the port A and port C upper will act as an output port, and we want to make this as an mode 0 IO operation mode. We want to operate the 8255 in the mode 0 IO function mode, and also port B and port C lowered as an input port. Control 8255 is not knows it just by reading the control register. So that's why it only reads the port B and as an input port. So LDA 8001. So whatever may be the bit pattern loaded into the just by pressing the switch, which switch is on, which switch is off, that is read by this port B. So port B address is 8001. So LDA 8001 means port B configuration is loaded into the accumulator, and corresponding bit pattern is output into the port A. So that bit pattern that is loaded into the accumulator is again going to the 8000, that means port A. So we have to read the switches pattern of the port B and send it back to the port A. Just like that, port C we have to, and port C, the one difference is that C upper and C lower has got the same address. So that's why we have to make some minor modifications here. We have read the switches at port C. So port C is 4-bit plus 4-bit, all the 8-bit is corresponding to, like that. And again we have to multiply the pattern with 0F. So if we multiply the port C bit pattern, 8-bit bit pattern, with 0F, then only the lower bit pattern is only we are getting the lower bit pattern. The upper bit is multiplied with 0, so upper bit is always 0. Okay, so we have multiplied ANI 0F hex. So we have marks the upper 4-bit of port C. Okay, so these bits are not the input data. So we are reading the input data from the port C lower, and we have to output that corresponding bit pattern into the C upper. So that's why we make RLC command 4 times. We have make RLC command 4 times, RLC. So that's why whatever may be the bit pattern, first we multiply C upper and the C lower, whatever may be the bit pattern 1 2 3 4, 1 2 3 4, we have multiply with F, and here 0 0 0 0. So whatever bit pattern and the C lower holds, that we get. After that, whatever bit pattern we get here 0 0 0 0, and any bit pattern, suppose 1 1 0 1, like that. Next we have to make 4 RLC operation. After 4 RLC operation, the bits comes into here. So 1 1 0 1 and 0 0 0 0. So we get whatever bit pattern in the C lower, we get same at the C upper. Then we again output the bit pattern into port C. Now in the port C, in more specific term, it is outputting in the port C upper. That means that bit pattern is loaded into the port C. So that we want to see at the port C upper. So that is the main operation of the program. So here the main tricky part is that the port C, which has some address. Okay, this is the port C address, but we have C lower will act as an input port and C upper will act as an output port. So the tricky part is there that the same port C lower and port C upper will act as an input and output port. We have to make arrangement that, so that we have multiply the port C data with 0F. After multiplying with 0F, we get the C lower data, and again whatever data we are getting after performing 4 RLC operation, that data, this data, suppose after performing with AND operation with 0F, we get 0 and some sort of data here, and that data must to be transferred into the C upper section, that is will act as an output port. So we perform 4 RLC operation, and after performing 4 RLC operation, the data will come here, and we have to again make this data to go back to again the port C address. And here again, after sending the data to port C, the port C upper will act as an output port, and that is displayed in the output section. So that is the main part of discussing the port C, how port C will get the same address, and if it is got the same address, how it will act as an input port and output port. That is the main discussion in the main discussion of this program. Next, the bit set and reset mode. In the bit set and reset mode, here we are only concerned with the 8 bits of port C. That means here we only concerned with the port C, not port A and port B. So in the port C there is 8 bit, 1 2 3 4 5 6 7 8, and this any of these 8 bit can be set and reset. Set means 1 and reset means 0 with the help of this BSR mode. That is the main function of the BSR mode. Now the control word is loaded first to make that this is a BSR mode. So as you know that to make it happens as a BSR mode, in the previous example we had discussed as an IO mode. So in the case of the IO mode, bit D7 of the control word is set to 1. But if it will act as an BSR mode, it will set to 0. Bit D7 is set to 0. It will act as an BSR mode. So next 3 bit D6, D5 and D4. If it is 0, then the control word of the 8255 will know it will act. You want to act 8255 as an BSR mode. So next 3 bit will decide the bit pattern of the port C. Okay. And next, this is your bit select, and this is your set and reset. Okay. So this is generally set to 0. Now this bit select, 3 bit select line, if it is 0 0 0, then bit 0 will be selected. If it is 0 0 1, then the bit 1 will be selected, and correspondingly if it is 1 1 1, bit 7 will be selected. So to load the control word format, first we have to set this D7 equal to 0. These 3 bits is not in use, set to 0. And next D3, D2 and D1 is set to, if it is set to 0 0 0, it will act as bit 0 of the C, port C. This is the D0 bit of port C, this is the D7 bit of port C. So if it is D3, D2, D1 is 0 0 0, so it will select the bit D0. And this set equal to 1, reset equal to 0. If you want to set the bit D0 of the port C equal to 1 or set, then we will set 1 and 0 0 0, and these 3 will always 0 and this is 0. Next, there is an example, write an BSR control word to set bit PC7 and PC3 and reset them after 10 milliseconds. Now the main thing is that if you want to set the bit PC7 and PC3, I have said that to set the bit PC7, 0 is loaded. This is for the BSR mode. This 3 bit is initially set to 0 for all the cases, and D3, D2 and D1, if it is 1 1 1 means PC7, that means bit 7 of the port C is selected, and to set the bit port 7, it is 1 is loaded. So pattern is 0F. Now if you want to reset the PC7, then 0 is loaded. If you want to set the PC3, same again, this is 0, this will be 0 for all the cases. This is 0 1 1, 0 1 1 is for PC3. 3 bit C3 bit. It will select the C3 bit, and if you want to set it 1, then it is set to 1. This is 07 and it is 06. So these are all the bit pattern to set or reset the corresponding bit. Next, there is a sample program. First we will load 0F. 0F means to set the PC7, and next out 83. That means we want to make the whatever may be the bit pattern, we send it to port C. Next 07, we send it to port C. That means port C7 is 1, port C3 is 1. Now we call a 10 millisecond delay. This will be discussed in delay and subroutine section. Next we again load 06 to reset the PC3 and again send to port C. And next we will load 0E. This will reset PC7 and send back to port C. Then we return to the main program. Okay. So this will be a sample program to set and reset at the port C, port C 7 bit and port C 3rd bit, to set and reset it after 10 millisecond delay. So first thing is that the main pattern of the BSR mode is it will only concern with the port C. No other port will be affected. So pattern is D7, and after 3 bit D6, D5 and D4, this will set to 0 for all the cases. Next D4, D3, D2, D1 and D0. Now the D0 is 1 for set operation and 0 for reset operation, and these 3 bit will select the corresponding bit of port C. If you want to set the 4th bit of port C, then we will load 100, as simple as that, 0. So this will the whole, and if you want to set the port C4, then we make it 1, here 1. So here make it 1 and selecting the port 4, bit 4 of the port C, then we can make 4th bit of port C set to 1. So this will be all the 3 will be controller format of the BSR mode to set the bit 4 of the port C. So this is as simple as that. Thank you.